Good evening, everyone. I'm Abhiroop Mukherjee, and yes, so yeah, I'm here to like brief you about the basics of pointer. So let me share my screen. Uh, Entire screen, yes. Is my screen visible? Yes. So my basic idea for the my basic plan for this session is to brief start from the basics of pointers, and by the end of it I will have a bubble sort algorithm which can work with any type. So let's get started. So uh, like pointer is a data type which stores address of some value. Now I guess these words will be somewhat confusing, so let me start with what an address is. So you can think of memory as pieces of data. Every data is 1 byte, and every every box have some address by which CPU can memory that access that data. So for example, 012 dot dot dot. So and the data can be something like 2, 3, 4, something. So we can the CPU accesses address 0 and gets data 2. So we can see this by the following program. So let me just type int a is equal to 10 and printf percentage %p slash n address of a. So what percentage p stands for is pointer. So it will essentially print the address of a. Okay, so let me just GCC. By the way, is the font visible? Like, do I have to increase the font size? Okay, it's not visible. So great. Now is it visible? Cool. So little more. Now, cool. So let me. There, I have declared an int a, and I'm using this and character, which stands for address of operator, and printing it in console. So here I will get address of a in the output. So GCC 0 underscore basic and then slash a dot out. So here we see some random characters. This means this is the address of a in the program. So let me just now start with pointer. So what pointer does is that it saves the addresses of data. So because we are using int a, we can define something like int star a, which int star a ptr. This defines a pointer which stores the address of int values. So it will only store addresses of data which have type int. So int a aptr is equal to address of a. Okay, and then we can just print and aptr. So the same thing, we get another address, but this is different from this because like every time memory gets allocated per program. So is everything clear till now? Yes. Cool. So let me go with what was the agenda. Next one, address of a pointer. Okay, now we start with dereferencing. So we have, so let me draw what is happening over here for better understanding. So here, draw. So we have int a with value 10. So a, and there is another aptr which we have defined, which stores the value of address of A. So if address of A, let be alpha, using A pointer. And we can do this via dereferencing. So what we can do is, like, let me delete this printf. Uh, printf. Let me just print A first. Value of A is percent percentage d comma A. Okay, so this is, we are directly using A to get the data of A. All right. So now, so dereferencing. So what we will do is that we will use A pointer to get the value of the data which A pointer has the address of. So printf value of A using its pointer APTR percentage D and A, A, APT. So what I have used here is just this star, which is called dereference operator. So what it does is that it reads APTR first, then it it uses the data of APTR, which is alpha in this example, and calls for alpha. Ask, wait, let me rephrase that. So we read alpha from APTR. Now CPU will get the data of the memory which has alpha as its address. So it will get 10 when we use dereference of pointer. So let me just do it again. Oops, add new lines. Okay, so we see that both way we have access 10. Uh, okay, so is it clear till now? Uh, like, I'm asking multiple times because these are basics and it will be used many times. Cool. So next one is called pointer arithmetic. So let me just start with a basic example. You all know what will happen if I print f percentage d fraction a plus 2. Can you guess what will this output? What will be the output of this? 12. Cool. So correct. So fun part, fun or like confusing part with with pointer arithmetic is that if A is, like, imagine if A is a pointer, like, that's in star. Let me just define something first. So let me define an array int A. Example, I would like to just mention that A here what happens internally. So I've defined an array of 5 element with data 54321. Actually, like, inside the memory, what happens is that the, the program, uh, the array will be made like 5, and ARR name, that is ARR, will be a pointer to this array. So ARR. Okay, so this will be internal structure. So there will be a pointer named the same as the array name, and it will point to an array. It will point to a location of memory which has the array. Okay, so percentage d value of AR. So what will value of ARR do is that it will first, the ARR points to the like the start of the array, and if we dereference it, we will get 5. So okay, so we are getting 5, uh, but now the catch is that imagine, how can I say, let's start with add, like imagine the address of 5, start of 5 is alpha, and we also know like size of int is the size of int is 4. So can I say that this will be alpha plus 4, and this will be alpha plus 8, and this will be alpha plus 12? uh, is everything cool what I've told just now? uh, am I audible now? uh, where did I freeze? uh, Long time. Okay, so is it like, was my audio visible when I was telling all this? Like, cool. So, okay, so let's continue. My question now is that what will happen if I do something like ARR plus 1? My question is that what will happen here? Can you all guess what will happen? Person has the idea. So what happens here is that ARR plus 1, in like if we were dealing with normal array, ARR, if ARR was alpha, ARR plus 1 would have been alpha plus 1. But things are different with pointer. So what happens is that when we do ARR plus X, if ARR is a pointer, what happens is that alpha plus uh, size of int star X. This is what happens. So what we, when we do ARR plus 1, instead of this result becoming alpha plus 1, it becomes alpha plus 4. So because, and when we dereference it, it reads the 4 byte from the memory, and then dereferences it to get 4. Okay, so let me just get again. We are getting 4. So uh, is everything clear till now? The thing I have just said. Cool. So, okay, so just for practice, let me just ask what will happen if I do uh, 5. What will happen here? Yes, I'm coming to that, Jatin, but my question, what will happen here? Okay. So Ritvik was correct. It was some random value. So what is happening is that when we do this, it's ARR plus 5. So ARR plus 5 will point to this. So let me just write the indexes. This was 0, 1, 2, 3, 4. It will point to this part. So alpha plus 16, 20. The ARR plus 5 will become alpha plus 20, and then it will read 4 bytes, and it will be random value, like some garbage value. So we have to be careful whenever we do reference and stuff, that we don't go out of array, because it will not give any error, but inside the function, inside the program, but like bugs can appear. Okay, so let's notch it up a little. Is array of string. Okay, so let me just try it. Char star strings equal to abc bcb cd. Uh, so so what? Okay, so let me just make a visualization of what this lines generates. Yes. Okay, so there's an array, right? So because I have defined an array, it has three values, and each of this value points to another array of characters where like it will be a b c slash 0. This will be b c d slash 0, and this will be c d e slash 0, and strings will point to them. So is this figure is somewhat understandable? This figure. Good. So my question is, I want to get this C. So how could we do it? So let me just give one way to do it. Printf percentage C dash n. So string, we have to get this C. So it is of index 1, like, so it will be strings 1, and then it is the second character. So again 1. Okay, so we are getting C. So this was very similar to what generally happens. Uh, am I audible? Okay, I was getting internet problems. Really sorry about that. Okay, so can now given like I've told one way to do it, can we do it by pointer arithmetic? So my question is that without using this square bracket format, can we get this C using just pointer dereference and pointer arithmetic? So I want some guess answers. Like, can you guess what will it will be? We want to get this same letter. Okay. How are we able to use two-dimensional array from one-dimensional array? Okay, so uh, okay, so what this is a two-dimensional array. How I'm defining? So there is nothing called strings in C. Like we did define C as an array of characters. So what is happening here? That Fred, this is an array. This is an array. This is an array, and strings is an array which has pointer which has pointers, like which has pointers to these array. So all these types are car stars. So here out Jatin. Cool. So okay, but we have one guess. Let's try Anurag first. Value of string plus 5. So let's see what will happen if we do strings plus 5. This is strings and plus 5. So this is 1, this is 2, this is 3, this is 4, this is 5. So strings plus 5 will give some garbage value. So does this clear, Anurag? Why should we not do strings plus 5? Okay, so let's try Neeraj's answer. So it is strings plus 1. Okay, so happening here, string plus 1. So let's do black, blue. Strings plus 1 points here. Then we are adding another plus 1. Then we are double star. So one star will be pointing to this and another star will give error because we cannot dereference. Okay, this, okay, this will point to this and good idea. Good idea. So value of string plus okay, so you can see that we are getting some garbage value. Can you see that this question mark when we do strings plus 5? Uh, okay, and let's try Neeraj's answer. So okay, so we are directly okay strings. Oops. We are getting C. So we are getting this value rather than this one because what is happening is that strings plus 1 is this one, strings plus 1 another this one, and we are dereferencing it twice. So this one, but it's not what we want. So let me just define what we have to do. We have to initialize, increment string by 1. What, let's do pink, brown. Uh, let's okay, so we do string plus 1, so we will get here. Then we dereference it to get to this string, and then we increment it again to get to C, and then we dereference it to get to C. So it will be first we do strings plus 1, then we dereference it, then we add another one, then we dereference it. Okay, so what I did just now, was it okay? Jatin guessed it right. Jatin guessed it right. Okay, so my next question is like, uh, I want to get this B. What will be the answer? Like, what should I put here? Okay, let's first Neeraj's answer. So it is value of string plus one. Okay, we are directly give Neeraj, your answer is wrong because the compiler itself is not accepting. Let's try Anurag's. Cool. So let me just define what is happening here. So let's choose a let's do rainbow for this. So strings plus one. Okay, even this is wrong, but it gave correct answer. So what this one is doing is that there is strings plus one. So we are getting here. Then we are dereferencing it once to get here. And then we are dereferencing it again to get this B. Okay, so this was also wrong, but close enough. So I commend you. So let's actually see what is happening. So we start with string, then we dereference it here, then we add plus one and dereference. So we have strings and plus zero. Okay, so this is pointing to here. Then we dereference it once. So we are here. Then we increment it one to get here. Then we again dereference it to get B. So okay. So what I did just now was that here. Cool. So let's get to next topic, which is swapping. Uh, oh yes, yes. Okay, so basics is I can say that it is pretty much done. So I'm just waiting for some more time. If you have any question, doubt regarding what has happened till now, you are free to ask. Okay, instead of doing cast star, what if we do string? As I said before, string as a data type is not present in C. So, so using something like string here will direct give error because string is not a data type. See, identified string is undefined. See, in string.h is like it's like type. It has been create like in string.h the string data type is like a, is only character star only. It has been hash defined or type def by inside string.h. So internally everything happens using char star only. Does that clear it, Neeraj? Yes, it's same. That is what I was trying to say. No, just okay. So let me continue to swapping part. So So let's just start with a basic example. So int a is equal to 10, int b is equal to 20, and we have to swap it int f percentage d percentage e percentage e in here so that values of a and b can be swapped. Okay, I guess there is still doubt. So before doing anything of this, let's just first define what a string is. So string is a array of characters. Like in C, we define string as an array of characters. So if uh, our string 10 is equal to A, B, C, D, E. So what happens here, like also let's do printf percentages string. Okay, so okay, so what internally lines generate is, let me just, I can save here. Let's keep it. Uh, okay, so what this generates is a 10 sized array, which has character A, B, C, D, E, and slash zeros till, like there are 10 elements where first 5 is character and everything else is no, slash zero. Okay, so we define string as an array of characters, and this string, the string name itself will point here. Okay, so if for example we want to get this, like we want to print D, so what will it be? String, either it will be string of what, 0, 1, 2, 3, string of 3, or it can be something like value of string plus 3. Okay, so it's just like, so what a string in other language is a character of array in C, and it is just like an array and we can do whatever we want with it. So does that clear, Neeraj, the doubt about string and character array? Uh, okay, all right, then let's continue what I was doing. So yes, my question was that we need to do something here. So we need to do something such that a and b, value of a and b gets swapped. So what I want is that a becomes 20 and b becomes 10. So any guesses what can we do? Take a temp value. Good. So what I guess Nikhilesh is referring to is that we define another temp is equal to a, then a is equal to b, and b is equal to temp. So what happens, like if we move step by step, so uh, let's just define something like a, b, temp. So initially a was 10, 20, and temp was garbage value. When we do first line, it becomes 10, 20, 10. Then we do a is equal to b. So uh, it's uh, this becomes 20, this becomes 20, this becomes 10. Then we do a is equal, then we do b is equal to temp. So b becomes temp. So 20, 10, 20, and 10. And like we can see that initially is for 10, 20, then it's become 20, 10. So swap is successful. Let's test it out. Cool. So this was basic idea. Now, you can see that these three lines, copying these three lines multiple time if we want to do swap is line consuming and noise in main code. So what if we want to make a function? So like something like we can do swap a b, something like this, and a and b values just swaps. So what can we do about it? So So let's define a swap function. Like we create a function and call it many times when we don't want to swap. So let's define it void swap int a, int b, and then we just copy this here. Then what we just call it swap a b. So so let's just run it. Okay, the swap did not happen. Like you can see that it's still 10, 20. Like a is still 10 and b is still 20. So can someone guess what happened? Okay, yeah, nucleation, Jatin. Addition and subtraction is also possible, but uh, I will move to something other than int in the future. So those will not be possible. If for imagine int is string, like we are swapping string, so this plus and minus will not be possible. Okay, so let's pass it by value, not reference. Okay. Okay, I want to clear something. Anurag, reference as an entity does not exist in C. So we cannot pass by reference here. It's possible in C++, but it's not possible here. Okay, Gaurav predicted something, value passes. Copy of values are passed. Okay, so that just define what happens here. So, and okay, even before that, I want to tell what actually happens when we run a program. So what happens in memory. So when we run a program, like when we do dot slash a dot out, memory gets allocated for this program to run. And that memory allocation is done by operating system. So memory in C memory, C like the memory for the C program is divided into four parts. One is text, one is stack, one is heap, and one is uh, data. So text, as the name implies, just includes everything we write here in assembly, of course, but every instruction we write here resides in text part. Data, so code, data is for global and static. So here we are not using it, but if in some program we are using global variables and static variable, data, it resides in data part of the memory. Stack is for call stacks and local variable, and heap is for dynamic memory allocation. We will touch upon these two now. So just to be clear, is this all right? Uh, is this okay what I have written? Is it? Yes, cool. So so stack as in like I'm going into stack now. So stack is what? First in, first out. No, sorry, last in, first out. So oops. So what when the program starts, there is a main function. So initially there will be a stack element for main, it will have what? There is A, there is B. Okay, when we call it, when we call any function, a stack element gets created for that function, and every every data inside it gets copied to that swap. So what is happening here is that this A is equal to 20 and B is equal to 20. These data gets copied into function parameters A and B. So here A is equal to 10, B is equal to 20. Okay, so now now any changes we do here gets reflected upon only this local variables inside this file. So the any edit we did here reflects to these only, not the actual parameters. So because of it, the actual A and B are not touched and their values are not changed. So is it okay what I said told? Cool. So we found what is causing it. Now let's see how do we solve it. So hint the answer is pointer. So what we do here is that rather than directly getting A and B, we get addresses of A and B. So what happens if, like, in main stack, if A and B, if A and B are in some location alpha and beta, we can access this main stack element if we get hold of these addresses using pointer, dereference, and reference. Okay, so what we do is that rather than getting the value of A and B, we get their address, and then with pointers we can edit and change these values also. Okay, so let me just write what happens. So we are taking input at pointer, we are getting input of address, so we will store it in two pointers, A and B. That's mean APTR and BPTR. Okay, so what will it be? Int temp is equal to value of APTR, and then value of APTR is equal to value of BPTR, and then value of BPTR is equal to temp. And then we are passing address to this function, so it will be address of A and address of B. So let's test it. Oops, I added address wrong in the wrong place. Okay, so we can see that initially A was 10, B was 20, and now it's 20 and 10. So is this part okay? Like how call by how this calling works? Okay, and another thing, this type of calling, like this type of calling is called by pointers. Like if we are going into specific term, this is called call by pointers because we are using pointers here. Okay, so now our next objective is to make it type independent. So you can imagine if, like, we are swap, if we want to swap, for example, characters. Like imagine this is a character A is equal to A, this is character B is equal to B, and then do swap and everything. But we cannot do it here because int, like, even if okay, we cannot do it here because this swap expects an integer pointer. So when we do this, we will get an error. Like there is stack smashing, like there is error. So one way to solve this is that we create another swap function where like do it char, then do it char, and it's going we have to do something like this, and hopefully it should all work. Right. Okay. Just to clarify, these values are ASCII values of A and B. Okay, so we can do something like this, but there's a problem here. So what if after after coding everything we want to swap like structure or strings or something else entirely? We have to create same thing again and again for different types, just changing this type wherever we go. So you can see that this is bad, like too much noise. So what could we do to make this type independent? Okay, so okay, so are you all getting the objective of why we are doing it? Like why we want to make everything this one type independent? Okay, Neeraj is on the right track. So what we do is that there is in C there is something called void pointers. So void point before going into void pointers, I would just like to tell what void pointer actually is. So void pointer is a pointer which has no type. Its data type is void. But as we all know, we cannot have void data. So there are two things about void pointer which should be noted. One is that we cannot dereference it. So void one, no dereference. So we cannot directly dereference void pointer because like if we dereference void pointer, what will be it? Its type is void, which is not defined like in C. So another thing is that uh, initially, okay, I've erased it. So uh, I the, okay, so I told before that in pointer arithmetic we use something called size of to size of data. Let it be t. But you can see that void is no type, so we cannot use pointer arithmetic over here also. So we cannot do pointer arithmetic here also. Like even if we force it to do, it will act just like a normal integer. So if this is a pointer, if this is alpha, pointer ptr plus 1 will be alpha plus 1 only. But this property is supported by some compiler only, and some compiler downright ignore, like gives error. So I would suggest not to do pointer arithmetic with void star. Okay, so is there any doubt here? If we don't, then we have to write same thing again. Yes, I was exactly. Uh, like okay, so the question is how do we use void pointer? So one way is that we can like okay, so it's clear that we have to use void pointer because like we have to do it generic. So the idea here is that we uh, get input of pointers using void pointer and then do something here. So that swaps takes place. So one way to do it is like to just void star and do it void star, and then we just typecast everything to int star, int star, int star, int star. Okay, so one way is doing this, but you can see that this is also a very bad way because we are defining what type of data it will be. So this will work, but it will again fail with different data types like structure or string. So for this, we use something called memcpy. So let me just tell what man CPI is. Man CPI. Okay, so mem CPY copy memory area. So what it does is that it copies n. Okay, function copies n bytes from memory area SRT to memory area destination. So if we do memcpy, what will it do? It will copy. Okay, let me just first give example. Okay, so let's do this. Okay, so we will do void star c is equal to malloc. Okay, so with now our objective is to just copy one line, this line one. So what we are doing here is that first we are making a temporary variable, then copy the data, right? So first we will create in temp in generic form. So we are doing malloc here. So what malloc does is that it creates some data in heap part. Okay, so we are doing malloc and size of int and size. Okay, we can do something of size of int. But you can see that if we are doing int, this will not work with string or anybody. So it's better to we give another parameter size underscore p lm size. Now this size underscore t is just a type def for unsigned long. So like we generally use this for to define size of something. So essentially it's an int, like it's an integer or long. It just defines what the size of element will be. Okay, so lm size. So we did int temp. Then we have to copy the data of APTR to temp. So before going else, let me just draw what is happening. So we created some data, which size is lm size, and c points to starting of it. Okay, now we have, and we also have a pointer and b pointer, which points to their respective data. Now we have to do first line, which means the data of temp is equal to data of APTR. So we have to copy this part to this part. Okay, so it will be mem cpy. First is destination, so destination will be C. Then source will be APTR. Then number of bytes, so n, it will be lm size. Okay, so we have done first line. Then second point means that A's data becomes B's data. So it will be, its destination will be A, PTR, source will be B, PTR, and lm size remains same. Then third line is data of B becomes data of temp. So in our case, it is C. So this becomes BPTR and it becomes C. And now this swapping is done, but because we have done malloc, we have to free it. So free C. Okay, now we have in theory a swap function. Now we have to actually do it. So it will be address of A, address of B, and then another parameter is size of element. So it will be size of char. So let's test it. Okay, not error. We have to include stdlib. Okay, so for malloc we have to include stdlib. like. And for memcpy, we need string. Okay, so let's try it again. Okay, it is not. Wait, let me just do it. Okay, so we can see initially it was 1 2, then it becomes 2 1. So is the the thing which I did here, was it clear? Uh, okay, so let's try another more examples to just clear it perfectly. So let's define uh, okay, 5 is equal to ABC. Is 5 is equal to BC. Okay, size of star. Okay, so as you can see, this is making some problems. So can you guess what happens here? Like why we are getting some error? Like I did same thing. I defined something and we are just giving their address and we are doing it. So yes, so uh, okay, the thing about heap is that we ask from OS to get the data and it does not get deallocated by itself. So imagine we have this memory. We have this memory. We like there are different parts. Let's this see this heap. Yeah. So now if we do something malloc, the program will ask OS for some data. Okay, but uh, but because this is we are doing it by ourselves, we also have to tell when to free this data. That's why we are using C. Like for example, if we don't use C, for every call of this swap, new data will get formed, and after some time, the heap will be full and there will be abort, like force abort will happen. So does that clear, Neeraj? Yes, like not only heap memory, even memory is like everything is limited here. So if we continually allocate memory, there will be a time when memory will get full. Then OS will have to force terminate that program. So it's not a good practice, but it is a necessity that we keep deallocating the data we allocate and do not need it again. After program ends, we will reallocate. Okay, after the program ends, okay. So when we do something like ./a.out, OS makes some memory for program to run, which also includes heap, stack, text, everything. So when this execution gets completed, all the data will be freed. So is that okay? Cool. So so the main thing was why this is failing. So for that, let's just first draw a diagram. So we have STRA, okay, and this is A B C /0/0, and this is STRB. This is B C D /0/0, and then we are doing swap. So yeah, so what is happening is that we are giving pointer to these values. So we gave address alpha and beta, let's say. So APTR becomes alpha and BBTR becomes alpha. Okay, so after that we do memcpy. So STRA and STRB will get swapped. So initially, so what will happen is that STRB and this is STRA, and after that printf happens. So is that clear how this runs? Okay, so let's go to next part, which is bubble sort. So here, like, I've defined a direct bubble sort here, and like basic swap. So essentially just a bubble sort for int. So let's just test it. Yeah, so there was initially array 5 bubble sort, and then we are doing 1 2 3 4 5. So our, like, the next objective is to generic make it generic. So let's first try this swap only. Let's bring this swap. And now this swap requires another thing, so we have to pass another array underscore t length size. Length size. Size of. Okay, here I need std. Okay, so same thing happened here. Like we just use these generic swap inside the bubble sort, and same thing happened. Now our objective is to also get rid of int star. So now main problem happens is that this comparator. that- Wait, when moving before that, is everything clear till now? Okay, Sam, are you talking about the size of int we are defining in main, Sam? Yes. So, uh, okay, okay. So, like main is like we are just using functions, right? So in main we can define what this can be using input, output, and everything. So it is okay if we define it here, because like after that we can also define it something else and sorting will be done accordingly. So it is perfectly okay if we define it here. But inside the function, if we do, the function becomes type dependent. Okay, so Sam does that. Okay. So now in the bubble sort, there is one, like if we do void star, there's a problem. Main problems is here. We cannot do this type of things. Like we cannot do compare is which is used in bubble sort. So how can we solve it? So there is something called pointer to function. So as I said before, there are different types of data in a C memory. Like in the text, we have the actual code. So we can have pointer to the code segment itself. Okay, so function pointer will be a pointer which stores address of the function defined in the text part of memory. So let me just give an example. Okay, so imagine this is the memory during program execution. This is text part, and imagine there is a function here, and it also has some address like alpha. So we can have some pointers which stores this alpha also. And why we are doing is that using this type of pointer we can in a way pass our custom functions to it, so that uh, the inside thing can directly call to this function for its execution. So I guess this will be confusing. Let me just give an example. So format it. So we define a function pointer as it will be first it will be return type. So here this returns a boolean value. So bool, then uh, comparator function. So the reason I'm doing bracket here, because generally if we don't do, and this is a parameter, if we don't do if we don't use the brackets, it the compiler thinks it as bool star comparator, but we want a pointer to function. So it will be bracketing it like this. Then we declare the pointer. So const, we are we are using int, but we cannot write int here. So let it be void star a, void star b. Uh, okay, so our objective is to abstract this into a function. So let me just create another function. I'm doing int, right? So int comparator void star a void star b return. We are doing this, right? So we just have to compare int. So we just first typecast it to int star. And value. Okay, so I guess I think that this is still confusing, right? So let me clear what is happening here. Like, let's go it step by step. Let me just define what is happening in int comparator. So in int comparator, we have a which points to some data and b that points to some data. Now, because we are comparing with int, I'm typecasting it to a and then getting its value. So this was void star. We make it int star, then get the value. So data will be four bytes here, and this will be 4 bytes. Now the reason I am doing int star here, I will tell it why, but just bear with me, okay? So so here, rather than doing this, we can do something like if uh, so I guess this will be hard, but the basic idea which I'm thinking is that rather than doing, I am abstracting it to some function so that we can pass that function according to our need. So is that somewhat okay? Because ge- I will get more inside it after this. So okay, okay. So let's do it. Like, let's talk what is actually happening when we are doing this bubble sort. So initially we have, like in this example, we have an array, right? So this is 5 4 5 4 3 2 1, and we are passing starting of at address arr, then size of int, and another function which is just for comparator. So now uh, we have typecasted that pointer to void star. So as I said before, we cannot do arithmetic with void star. So, and even void star, if it is supported, it always happen plus one only. So if this is alpha, this will be alpha plus 4, this will be alpha plus 8, this will be alpha plus 12. So if we, so the first thing is that we cannot do this type of operation because we are dereferencing void pointer here. Okay, so this is one problem. Another is that we cannot, like, ARRJ inherently means ARR plus J reference. Is this okay? Can I say that ARRJ is same as this? Cool. So there is two problems with it. First is that this dereference we cannot do with void, and this plus we cannot do it void. So how could we solve it? So as I said before, if ARR was int, ARR plus J is equivalent to ARR plus size of int times J. So can we do it manually? We have this size of int in element size, and ARR is known to us, and J is like in the loop. So can we do it something like this? So can we do something like ARR plus lm size rj? Can we do this? So if j is 0, if j is 0, ARR plus lm size stars j will be this, and if we replace j by j plus 1, it will be this. So essentially we are comparing these two. So is it okay? Why can I do this? Why? Okay, another problem is that this pointer addition. So one way to solve is that we know that size of character is 1 byte. So we can for now just typecast it to cat star, then full screen for it. So we know that value of char is 1. So this can this be done? Like we typecast ARR to char star such that every plus 1. So in character array, plus 1 is actually plus 1 because size of char is 1. So can we do it like this? And does it solve the void star problem? Like we cannot do pointer arithmetic and we cannot dereference it. Okay, so the thing is that void star cannot be wait, the question we need to typecast. See, so we cannot do pointer arithmetic with void. So if I remove char star, what is that? This is a void star and we are adding something to it, and this is not supported in every compiler. So because of that, we are typecasting it to char star because size of character is 1. So if ARR is char star, size of char is 1, so ARR plus value will happen every time. So does this solve, clear the doubt? Uh, okay, so let me repeat it. So what actually happens here is that okay, so we have an array. This is alpha. This is alpha plus 1. This is alpha plus 2. Dot 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 dot. alpha plus 3 and dot 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 dot. So this 4 is alpha plus 4. So 1, 2, 3, 4. These 4 bytes is actually 5. Can I say that? Then there is 4 and 3 again. Okay, so ARR points to here and ARR is void star. And we cannot do pointer arithmetic with void star. Like it is not supported in every compiler. So what we do is that given jth element, given we have to take jth element and lm size is given, we do ARR plus lm size star j. Okay, but pointer, like this is valid if every plus was 1. So if lm, okay, how should I convey it? How should I convey it? Okay, consider ARR was an int pointer. Okay, so lm star j. If, like, imagine j is 1, this is 1, lm size of this is 4, and this is an int pointer. So this gets solves to ARR plus 4. But we know that if ARR is int pointer, plus 4 actually means ARR plus size of int star 4. So can you see int star, like ARR was int star, there is another size multiplication with this. Uh, okay, so for solving that, we typecast it to char star so that that extra multiplication becomes size of char, and size of char is 1. So now is it clear? Okay, I know this is the confusing. Okay, so imagine ARR, like let's just avoid this. Okay, so what is this? ARR plus LM size star J. Now, problem with this is that one thing is that we cannot do pointer arithmetic with in ARR, like void star. So we have to do it like this. We cannot do it like this because it's void star. So let's just make this clear. This is an array. This is alpha. This is 0, 1, 2, 3. And we need to access 3 start of this value. So what will this be? Imagine this array is int. Okay, so if this array was int, this will be alpha plus 4, this will be alpha plus 8, this will be alpha plus 12. So can I say if j was 3, accessing third index element will be ARR plus 3, LM size is 4, so 4 into 3. Is this clear? This part. Like if we have to access jth element, how can we do it with? Cool. So now this is void star. So we have to typecast it to something for addition to work. Is this clear? What the sentence I said? Pointer arithmetic with void star is not possible. So we have to typecast it to something for pointer arithmetic to work. So let's assume we do it int because we are sorting it. So can you say if int ARR was int star array, ARR plus 12 will actually become ARR plus size of int into 12? Can you say this? Like, make it double sure. This is confusing, I know. That's why I'm repeating it many times. Uh, so can we say that if we do something, if we typecast into some type T, ARR plus size of lm size star j, lm size star j, this will actually become ARR plus lm size star j into size of t. Can we say that if we are typecasting it to t star? Uh, is everyone other than Neeraj okay with this? Cool. So now we see that this will hinder what we are doing. Like if we want to access jth element, it will actually give j into size of tth element. So one solution is to divide it by whatever we are doing. So if we in formula do ARR plus do it t star ARR lm star j by size of t. This is one way. So when we are accessing the data, this size of t and the denominator will get cancelled. Other way is to typecast it to some of that value which has size of t1, so we don't have to divide it even. And the size of char is 1. So does it make any sense why I am doing car star here? Cool. So this 100% confirmed. This is, I guess, the hardest part. That's why I'm asking so many times. Cool. So now ARR of j becomes this. So what will ARR j plus 1 become? Can I just say it like this? J plus 1 with another bracket. Let me refactor it such that it becomes good better. So first one was this, second parameter was this, and okay, there is bracket problem. Car star. So I'm calling comparator function and I am passing two addresses here. So greater than ARR J plus 1. Like, is it 100% clear why I am doing this for solving this? Cool. So now also we also cannot do this. So let me just copy it here. So is what I did here, was it 100% clear? Like, I just change ARRJ with this thing. Uh, Everyone else? Cool. So we went into nitty-gritty. Let's then see what is happening. So we are swapping and we are giving addresses here. So let's just figure out what actually is happening. Okay. So we have this enter 543 54321, and this void star ARR is actually here, and we are giving comparator function elements j and I. So for j is equal to 1, this will be this and this. Okay, so comparator function get two addresses, which are this and this. It first typecast it to int star. So this is now int star, this is int star, and then it dereferences it to get values 4 and 3. Then it compares and compares greater than and returns value. And similarly, when we call swap, we get two arrays, matlab, two pointers, same as this. Rather than typecasting it to int, we just uh, do mem cpy and everything. So voids like 1c will be defined for mem cpy a pointer element size. So this will be 4. Then a will become 3. Then in the third line, this will become 4. And then c is free. So is it okay? The bigger picture was clear. Uh, so bubble sort has the function to int comparator. So we can see that like the sorting is happening. So I'm waiting for some time. If there is any doubt, please ping me. I know this thing is hard. Okay, so let's move for different type of array. So this was only int pointer. Now let's try with array of string as I did before. So char star strings is equal to cpd now the objective is to like sort it lexicographically. So our ending answer will be ABC, BCD, and CBD. Okay, so as you can see here in bubbles, like in the parameters, in the parameter only we are giving the starting address size of an comparator function. So can you say that for defining how it will be sorted, we have to make another comparator function and pass it in the code? We can't compare without type. Yeah, okay, so in comparator we are free to do int because we will pass the entire function as a parameter in the sorting algorithm. So in case of string we can create another comparator specifically for strings and then pass it in the bubble sort algorithm. So does that clear, Neeraj? Cool. So let's make another comparator for string. So that is string comparator. Vector. Okay, before going that, let me draw again how this will behave because another typecasting will be necessary here. So what is this? This is three element. Yes, three element. One is pointing to CBD 0/0. This points to BCD, and this points to ABC, and strings is here. Okay, so this figure should be clear, right? The figure I have drawn about the array of string, this should be clear, right? Okay, so now if we do sort, this will be strings. Number of element is 3. The size of char star. Uh, we are doing char star here because the actual array, which has to be sorted, like this one, has pointers to character array. So this all will be char star. Okay, so and string comparator. Okay, and then we print it just for percentage. That's strings. Yeah. So what should be in string comparator? My question is that. So actually the parameter will be as same because we have defined the comparator parameter format here. So this will be void star b. Now in the comparator, okay, in the comparator, it is giving addresses to j and j plus 1th element. So let's assume these two uh, these two pointers are given. Okay, so can we say that these two data will be char double star? can we say that these two, the, the the A and B that we will receive in the string comparator is cast double star. So how I am telling is that ARR was actually car double star. ARR was car double star. Like it is a pointer to an array of car star. So this is car double star, and we are just adding data, like doing pointer arithmetic with it. So the value of these two will also be car double star. Okay, but here we are seeing that we are typecasting it to car star. That is just for like pointer arithmetic. We, like, you can safely avoid car star type conversion. So car star type conversion is just for this to be valid. Other than that, can you say that the result will be pointer to these two? Can you say this? Confirm. Okay. So these two A and B will be car double star. And so, and for string comparator, like we do man strcmp, we need pointer to actual string. So let me just recap. We have car double star here, and we need to access pointer to this, pointer to these two values. So what will it be? So first, I can safely do this car double star. So we are at these two. Then we have to get pointer to, we have to dereference it to get these strings. So this, is it okay? Why I am doing this? Like value of card. Let me choose bracket to make it more clear. Is it okay? Why are we doing this? Yes, yes, perfect, absolutely. So see, I guess this is confirmed. Key the point A and B will point to, will be car star arrays. So okay, so I can say that A and B will be car double star, right? So we are changing A and B to car double star to get these two values, like green pen, these two values, right? Now we, for string comparison, we need the actual string. We need these two strings. So can we get those by dereferencing the car double star pointer that we have? Cool. Does this make sense? What I did here? Okay, so this gives data of a pointer which we have to compare. So we just do this as return strcmp simply. So so I guess the function is over. Let's try this again. So few arguments for strcmp. Is there some bracket problem? There is a bracket problem. Now it should be. Segmentation fault. Ah, what is happening? Why is this happening? Because I'm doing the same thing, right? Did I miss it? Seems that I have encountered some problem. Just give me some time. Uh, okay. This was the problem. Yes. So, uh, sorry for the delay. The problem was not actually in function; it was uh, in the parameter here. So sorry about that. So does everything is clear? Comparator function is not clear. Okay. 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 So in the bubble sort, we are comparing this and jth plus one element. Like in bigger picture, can we say that we are comparing jth plus one element? Like, I am doing it step by step just to make everything clear. Can we say that in the comparator function, we are getting input of jth and jth plus one element? Yes. So can we say that we are getting if j is one, we are getting this two elements, and type of them will be same as type of strings, that is car double star, sorry. Can we say that type of both the element we get in A and B is car double star? Cool. So now for str string compare, we need pointer to actual data, actual strings. So can you say that we have to do one dereference to get the strings? So what I was meant to say that if A and B are car stars and we need to get their strings, can I do value of A and value of B to get the actual strings? Cool. So let me just complete it for others. So if A and B were char stars, we just have to do strcmp value of A and value of B. But here A and B are void stars, so we have to typecast it first to char stars array. So because of because of this, we are doing like we are typecasting it this much. Okay, so I hope this all is clear. And now I want to figure say that this all is complicated, right? But why did we do it? So main reason to do it is like main reason I did it this way is because uh, like there is an inbuilt sorting algorithm called qsort. So that uses quicksort algorithm, but the main thing is that how we call it man qsort. Okay, so there are parameters. I'm going it one by one. Void star base. What void star base means that we have to pass a pointer which is the base of array. And there is another thing, NMEMB, which is number of elements in array. So in this case, let me just write base will be strings. NEMB will be 3 because there are 3 elements in the array. Size means the size of array, size of elements. So can I say size is size of char star? And what last thing, int compare void star void star. So this is same as the function we defined, like it's a pointer to function. So so can you see that what I did, the parameter I passed here, similar thing factory function? Like if I do qsort and same thing, this should work. Is it like, do you get the idea why I did this mess, like pointer everything? Cool. So let me just do it with qsort also. So there is a documentation about comparator. It tells that the comparator function must return an integer less than equal to or greater than 0 if first argument is considered to be less than equal to and greater than 0 second. So in string comparator, we are just like and if you see strcmp as and strcmp, it also returns an integer less than equal to or greater than 0 if s1 is less than equal to and greater than 0. So can you see that this strcmp and what we want to do in qsort is compatible in the according to documentation? So if we run the algorithm, this is supposed to work. This is not. Okay, it is because the function wants constant void star. So let me just this. Okay. Oh, oops. And so we can see that with minimal changes, like just return type and just adding constant, we are we are calling a factory function, and we have made a sorting function which acts like other than the algorithm. It has parameters exactly same as bubble as qsort. So is my motive behind all this pointer things acceptable to you all? Okay, so with this I want to end it, but I want to end it with a good note, like what why we don't use it anymore. So in C++, they you know that this pointers thing is very confusing. So many times we are okay. I'm going into that first. So you have seen that there is a lot of confusion, and we are typecasting it to void and back and forth many times. So in C++, there is something called template, which with along with reference and everything completely removes the need of this pointer arithmetic. So that's a good thing. But in case you have to use C, you have to follow by this sets of rules. So okay, so this was the end note.